Our objectives for this lesson are the following: discuss basic properties of logarithms, illustrate laws on logarithms, expand logarithmic expressions, and condense logarithmic expressions. I suggest you take time to watch my lesson in Introduction to Logarithms to fully comprehend this lesson. Basic logarithmic properties. In logarithm of x to the base b, let b and x be real numbers, such that b is greater than 0 but not equal to 1. First property. The logarithm of b to the base b is equal to 1. Let us convert this into exponential form. So we have b raised to 1 is equal to b. And b raised to 1 is b. So b is equal to b. Therefore, this property is correct. So, if you have the logarithm of 7 to the base 7, automatic, the answer there is 1. So, the answer is 1 whenever your x is equal to your b. Next property, the logarithm of 1 to the base b is equal to 0. Let's convert this into exponential form. B raised to 0 is equal to 1. Isn't it that any number except 0 raised to 0 is equal to 1? So it means this property is correct. So whenever you are given, for example, the logarithm of 1 to the base square root of 5, the answer there is 0. So answer is 0 if your x is equal to 1 and your base is greater than 0 but not equal to 1. Next property, the logarithm of b raised to x to the base b is equal to x. Let's convert this again into exponential form. So we have b raised to x is equal to b raised to x, and they are equal. So this property is correct. Example, the logarithm of 7 to the 4th to the base 7, the answer is 4. So whatever is the exponent here, that will be your answer. It only happens when your x is equal to your base. Next property, if x is greater than 0, then b raised to the logarithm of x to the base b is equal to x. This is in exponential form. Let's convert it into logarithmic form. So we write the log, we copy our base, and then our answer in exponential becomes our x in logarithmic form, and then the answer is the exponent in exponential form. So the logarithm of x to the base b is equal to the logarithm of x to the base b. So this property is correct. So for instance, you have 0.5 raised to the log of 3 to the base 0.5. The answer here is 3. Let us have some more examples. So number 1, 8 raised to the logarithm of 4 to the base 8. This is property letter D. So the answer here is 4. Next one, our base here is 10 because there is no base written. This is common logarithm. So meaning our x and our b are the same. So the answer here is the exponent of your x. This is equal to 6. Property letter C. Another one, the logarithm of 1 to the base 1/2. To what number are you going to raise 1/2 to give you an answer of 1? And the answer here is 0. This is property letter B. And last one, you have the same x and b, property letter A. Therefore, the answer here is 1. Now, let us have laws on logarithms. So, let b be greater than 0 but not equal to 1. And let n be an element of real number. U and v are both greater than 0. Then, law number 1, the product law, the logarithm of u times v to the base b is equal to the logarithm of u to the base b plus the logarithm of v to the base b. So, you will notice that the factors here now become addends, as if the logarithm was distributed to each factors. Let's have an example. So this is our u and this is our v. So this will become the logarithm of u to the base b plus the logarithm of v to the base b. Now, applying properties of logarithm, if we have the same x and b, the answer to this expression is the exponent of your x. So, this expression is equal to 3. And this one is equal to 8. And 3 plus 8 is equal to 11. Next law, we have the quotient law. The logarithm of u over v to the base b is equal to the logarithm of u to the base b minus the logarithm of v to the base b. So in number 1, in product law, from multiplication, it become addition. In number 2, for quotient law, from division, it will become subtraction. So let's have an example. So this will become the logarithm of u to the base b minus the logarithm of v to the base b. Now, I'll express 81 as 9 squared. And basic property of logarithm, the answer to this expression is equal to the exponent. So that is 2. And then, same base with x, the answer here is 1. And 2 minus 1 is equal to 1. Number 3, power law. So the logarithm of u to the n to the base b is equal to n times the logarithm of u to the base b. So this n here, which is the exponent, is brought down here in front. So let's have an example. So applying the basic property, we can easily evaluate this. Since our x is equal to our b, then the answer here is the exponent, which is 7. Now, let us try to apply the power law. So let's bring down 7 here in front. And then let's copy 7. Let us evaluate this. X is equal to b, therefore this expression is equal to 1. So 7 times 1 is still 7. Last one is the root law. So the logarithm of nth root of m to the base b is equal to the logarithm of m raised to 1 over n to the base b. And then applying law number 3, the exponent was brought down in front. That's why it became 1 over n times the logarithm of m to the base b. So in here, the nth root, when you convert it into exponential form, the numerator is 1 and then the denominator is whatever the root is. Let's have an example. So we have the logarithm of the 7th root of 6 to the base 6. So let us convert 7th root. That will be equal to 1 over 7. So we have the logarithm of 6 raised to 1 over 7 to the base 6. Applying property of logarithms, our x and b are the same. So the answer to this expression is 1 over 7. Now let us apply the root law. So after we converted it into exponential form, let's break down the exponent here in front. So copy 1 over 7. And then evaluate the logarithm of 6 to the base 6, that is 1. So 1 over 7 times 1 is still 1 over 7. Now let us expand the following expressions. Number 1. So we have the logarithm of m times n squared to the base 10. Since there is no base written, automatic that is 10. This is a common logarithm. So applying the product law, this will become the logarithm of m plus the logarithm of n squared. So let's copy log m. And then applying power law, this 2 will be brought down here in front. So plus 2 log n. Next one, we have the logarithm of the quantity 5 over x raised to 5 to the base 5. So let us apply first the power law. So let's bring down 5 here in front. Next, let us isolate this 5 here. Let's copy it. And then this one, we can apply the quotient law. So this will become the logarithm of 5 to the base 5 minus the logarithm of x to the base 5. And then let us simplify this. So the logarithm of 5 to the base 5 is 1. So we have 5 times 1 minus the logarithm of x to the base 5. And then let us distribute 5 here. So this will become 5 times 1 is 5. And then 5 times the negative logarithm of x to the base 5 is minus 5 log of x to the base 5. Next one, let's have number 3. The logarithm of the cube root of x, y, z. So let us convert cube root into exponential form. That will be 1/3. So the logarithm of x, y, z raised to 1/3. Do not forget to enclose in parentheses the x, y, z. Otherwise, if you do not enclose it in parentheses, only z will be raised to 1/3. Now let us apply the power law. Let's bring down 1/3 here in front. So it will become 1/3 log of x, y, z. Then this one is product x times y times z. So we can apply the product law. So let us isolate 1/3 and then log x plus log y plus log z. And then let us distribute 1/3 here and here and in here. So we'll be having log of x over 3 plus log of y over 3 and log of z over 3. Let's have some more. Next, the logarithm of 35 to the base 3. So 35 here, so we're going to think of factors that when we multiplied will be equal to 35. So let us say 7 and 5. So this will become the logarithm of 7 times 5. This is product. Consider this as your u and this is your v. So this will become the logarithm of 7 to the base 3 plus the logarithm of 5 to the base 3. Next one. We have the logarithm of 4th root of 25 to the base 2. So first, let us convert our root into exponential form, so that will become 1/4. And then I'm going to express 25 as 5 squared. And then I can simplify my exponent. So 2 times 1 is 2 divided by 4. And then 2 over 4 is 1/2. Then I'll bring down this exponent here in front. So I have 1/2 log of 5 to the base 2. Let's have one more. So we have the logarithm of 2 cubed over 7. So this is quotient. So this will become the logarithm of 2 cubed minus the logarithm of 7. And then let's bring down 3 here in front. So it will become 3 log 2 minus log 7. I still have some space here. Let's have one more. So the logarithm of a times b times c cubed. So this is product. Let us expand this. So this will become the logarithm of a plus the logarithm of b plus the logarithm of c cubed. Then this 3 here, let's bring it down here. So it will become log a plus log b plus 3 log c. This time, let us condense. Number 1, we have the log of 8 plus log of 5. So addition using the product rule, this could be condensed into the logarithm of 8 times 5. And 8 times 5 is 40. So I have log of 40. Next one, the logarithm of x squared to the base 3 minus the logarithm of x cubed to the base 3. So minus, so it could be condensed using the quotient law. So this will be the logarithm of x squared over x cubed. And I can simplify this. I still have 1x in my denominator. So it will be the log of 1 over x to the base 3. The exponent of x here is 1, and if I'm going to bring my denominator up, the exponent will become -1. And then this exponent, I'll bring this down here. So I'll be having negative log of x to the base 3. Another one. So I have ln of x to the 5th minus ln of y. So again, subtraction. So this will become ln of x to the 5th over y. There is nothing more we can do here. So this is our final answer. Another one. So we have 2 times the log of 7 all over 3. So first, let me isolate 2 over 3 here. So this will be 2 over 3 times the log of 7. And then I'm going to bring up 2 over 3 here. I'm going to make it exponent of 7. So this will be log of 7 raised to 2/3. And then I'm going to convert this into radical form. So it will be log of cube root of 7 is squared. And 7 squared is 49. So I have the logarithm of the cube root of 49. Let's have some more. So I have here log of 4 plus log of 6 plus log of 3. Applying product law, this is log of 4 times 6 times 3. 4 times 6 is 24 times 3 is 72. So equals log of 72. Another one, ln of 2 plus ln x minus ln of quantity x minus 1. So these two first, applying product law, will be ln of 2x. Then copy minus ln of quantity x minus 1. And then this is minus, so applying quotient law, this will be ln of 2x divided by x minus 1. Last one, I'll bring up 10 here and I'll bring up 4 here. So this will be log of u to the 10th to the base 4 plus log of b to the 4th to the base 4. And then this is addition. So using product law, this could be simplified into the log of u to the 10th times v to the 4th to the base 4. Here is the summary of what we have discussed. It is time to check your understanding. Pause this video for more time. Let us answer. For number 1, though we have the same base and x, the answer here is not possible or not defined. Because remember, base should be greater than 0 but not equal to 1, and x also should be greater than 0. For number 2, the answer here is 9. For number 3, the answer here is negative 4. For this one, applying product law, this will be log of m cubed plus log of n squared. And then bring down 3 here in front as well as 2 here. So we will be having 3 log m plus 2 log n. And this one, product law also, so this will be log of quantity 3 times 4 times 5. 3 times 4 is 12, 12 times 5 is 60. So we have log of 60. Gets?